car, right?
Oh, yeah.
Especially if it's a new car.
How does that work? How does that
Oh,
work?
the lock and unlock, the computer in your car. Yeah,
Oh, wow.
yeah. And the smaller the car, the easier it is to hack into.
I think it stopped you from.
If you have a cheap Caprice Classic, nobody hacked into that. If you get a Prius, somebody can hack into it, and it gets a little bit scary, especially if you have the OnStar system.
Yeah,
Yeah, they can tag into it. And there was actually a few accidents where people actually got like their brake locked in the highway. The car accelerated. I'm not giving you any ideas, but you know, there's a range of things you could do. Did you do chapter 2?
Other questions?
Did those look familiar to you?
Yeah.
Yeah, we did those. These we did not. Okay. I'm not that far behind. So we're gonna go. Come up with the other.
What page is that on right
This is 58.
58.
58. Sam, what is a series circuit? Say whatever.
Oh, like fair line, every.
A circuit where the loads are one after the other.
They're, yeah, getting the voltage after it goes through one first, and then it
Okay.
goes to another one, and then goes to another.
That's it. What is it used for?
Safety.
Two things.
Safety.
Safety and control. Okay. What's a control circuit? It's a series circuit. It turn on or off a component. Is it clear? Okay. Safety devices in an electrical circuit are connected blank in blank with the load. Safety devices. Tim? Switches? Series. Henry, how are series circuits used in air conditioning equipment? We just said that, but you can repeat it. How are they connected? How they're used in the, we use for two things, either safety switches or controls.
Okay.
So, the current draw in a series circuit is what? A, the sum of each load in the circuit, the same throughout the entire circuit, divided by the number of loads in the circuit, none of the above, and Josh.
Same throughout the entire circuit.
Excellent. You got that? Current is the same. What happens to the voltage? Drops. Resistance? Huh?
Is it the same?
No?
Adds up.
Changes.
Resistance never stay the same, dude. You hurt my heart. You hurt my feelings, man. It's late at night, it's okay, I get it.
What was it? The resistance adds.
You see it now? The current draw. So the current in a series circuit stay the same. We did that last week, remember? When we connected in series, we took the clamp on, it was always the same. It was 0.02, wherever you go. So it should be the same. Okay. The voltage drop of a series circuit is what? The amount of voltage lost throughout any load, proportional to the resistance in that part of the circuit, equal to the voltage being applied to the circuit, all of the above. What do you think? We did that. Remember? Huh? Polio, I've doubts. Which one of those?
G.
No, let's read together. The voltage drop of a series circuit is the amount of voltage lost throughout any load, proportional to the resistance in that part of the circuit, equal to the voltage being applied to the circuit. Shots in the dark.
C?
I would think A.
I mean, the voltage.
Okay, let's think. The amount of voltage of lost throughout any load. It could not be the same. It cannot be. Because if you have one load on the other, it will have more voltage, right? B. Proportional to that resistance in the circuit. Yeah. Because at any part of that load here, if I put my voltage, my voltmeter here, I'm gonna measure the voltage drop in that load. So in here, the voltage will equal amperage times resistance. So it's proportional. So last time we saw the first part, the second part, it always drops. And at the end of the circuit, what we got? Zero. Everything gets consumed. Okay? Any questions, confusion, clarification?
What was it?
B. B. How would switches used as safety devices can be connected with respect to the load they are protecting? Gotcha. By the mean by how would the switches be connected? They mean either parallel or series.
Oh, series.
Series.
Yeah.
Otherwise, there's no point. Switch should cut off the circuit. Okay. Draw a circuit with a thermostat, low pressure switch, and high pressure switch used as safety control to protect the motor. I'll draw it for you. So what would that look like? This is my circuit. What is the first thing? Thermostat. Then what?
Low pressure.
Low pressure switch.
Low pressure switch.
Which one's more dangerous?
And what? High pressure switch?
Mm-hmm.
High pressure. This is high pressure. Low pressure switch. Then what? Motor. I'm gonna put it in here. There we go. In quiz 4, I'm gonna ask you about that. How to draw a circuit. I'll give you the components. These are in series, this is in parallel. I want you to draw them. Hopefully, it wouldn't be that too complicated. Okay, that's an interesting question. Two identical 115 volt light bulbs connected in series with 240 volts. What would happen? Hold on, let's pick. Mo. We're going in series, man. Mo.
Wouldn't they burn out?
Are you asking me or telling me?
That's a good question.
Think about it. It will burn out, right? Because the first one is rated at 115 and you shot it with 240. So the first one is gonna get 240 and it's gonna burn out. What do you think?
Should you wire it in parallel?
Yeah. But again, you're giving it more voltage than it's supposed to. So it will burn out. What happened when we connected those little light bulbs in series? When we wired it to they are rated at 120, we gave them at 120, but they were in series. What happened to them? They were very dim, right? So the opposite would happen. The first one will flash, and boom, it's gone. So they will burn out immediately. Okay? Draw a circuit with 4 electric heaters in series. Going to do that? Okay, I'm not doing that. What's the parallel circuit? No, but since should I? Why not?
Can help yourself, huh?
R1, R2, R3, R4. There you go. Complete circuit. What's a parallel circuit? Got it? Just say something.
Circuit that comes off from one.
Okay. You didn't Negative. No Red Bull tonight. There's.
A circuit with more than one path.
That's great. That's a good answer. That's a fantastic answer. Circuit with more than one path for the current, and that's a parallel circuit here. Okay. Parallel circuit are used in air conditioning industry too. Let's think now. Supply the correct line voltage to several circuits. Act as safety circuits. Divide the voltage between two major loads. All the above. Lance. Think again. They're trying to mislead you here. Think. Be an individual. Ah.
C, or,
Divide the voltage between two major loads. Supply the correct line voltage to several loads. So, the switches in any room, are they in parallel or series? Switches, I mean plugs.
Are they in series?
You really determined to put me in depression today. These receptacles in a room, are they connected in series or parallel? In parallel. You sure? Yeah. Please be sure. Whenever you go with your voltmeter and plug your leads into any receptacle, what do you get? 120. It has to be. You might be in a very old house that be connected in a very funky way, and you get different voltage. That means something wrong with your voltage. My house has actually, and the loads all connected in series. Yeah, it's very funny. So, anyways, so most loads are connected in parallel. So that means, what is the advantage that I'm getting now when I connect all these receptacles in parallel?
One goes out, they don't all go out.
That's one advantage. What else? Same voltage. Every component will get the same voltage. That's what happened to light bulbs in parallel in the lab last week. They were all bright. If you take one out, they still work. You try that. So it will be supply the correct line voltage to several circuits. You have any doubts? Jesus, you're good? Excellent. Okay, 14. Why are parallel circuits used in air conditioning industry? Again, we said two things already. Let's repeat them. Gabe, why do we use parallel circuit?
why do we use parallel circuits? Because you want to separate the voltage out and make sure everything's running right.
Okay, so Keith, we get the same voltage, and what else? We have more than one path. If one does go out, the other one will work. And what else? Redundancy. But let's say you can have two pumps in parallel. When one goes out, the other one will turn. So, and the most important part is to supply the right voltage. If you have a compressor, a fan, something else, you want them to work at the right voltage. Because if they don't get the right voltage, they do not work. Okay. True or false? The current draw of parallel circuit is the sum of the current of each branch. Everett. He did that last week.
It's true.
True. True. So the current coming here, we call this A. This is B. This is C. And this is D. So it will divide. So if you want to measure the current here, it will be 1, B, C, and D. And we did that also in the lab. We measured the current for each light bulb and we added them together. I think it was 1.5 amp and each one was 0.5 to get the same measurement. So that's true. If three circuits are connected in parallel with a power supply of 30 volt, what would be the voltage supplied to each circuit? Jesus. Nobody shout out, no shout outs. This is the eye of the needle. If three circuits are connected in parallel with a power supply of 30 volts, what would be the voltage supplied to each circuit? Like for here, if I I have 30 volts, only the voltage here, here, and here. Think again. Huh? 30. Because we just said that we want to maintain the voltage, right? It's not gonna divide because it's in parallel. It's not gonna add up because it's in parallel. And anyways, you cannot supply 30 and get 90. No way this will happen. It's like magic. This is voodoo. You should not like multiply. Voltage does not multiply unless you have a transformer. So it's 30. It's gonna be the same. If 210 volts loads were connected in parallel with 240 volts, what would happen? I like those what if scenarios. So they are connected in parallel with 240, but they need 115. What do you think will happen? What? Okay, there are in parallel, meaning everyone will get the same voltage, right? Which is what? 240. So boom, boom, they will burn out immediately. So not burn immediately burn out. Very quickly, it's like suddenly you see it happening individually. What is a series parallel circuit? This one over there. Combination. You have things in series and you have things in parallel. Why do we use a combination of series and parallel? Because we need control, we need safety, and we also have more than one load. That's what we do in our HVAC equipment. 19, 20. Draw a series parallel circuit with one switch controlling two electric heaters, each being supplied with line voltage. It's a creative art class, huh? Okay. Any volunteer? So draw. Come on, somebody volunteer. Go ahead. You can do it over there. The clean board. Here, go. So draw a series parallel circuit, which is a combination, one switch controlling two heaters being supplied with line voltage.
That, right?
Yeah?
Heater, whatever.
Yeah? Excellent.
Then they connect, right?
Yeah.
Just two of them. That's it?
Good.
Just the two of them?
Complete the circuit? Yeah. You're gonna put a switch
After or before?
before. That's a very good point because switches usually are in the hot line. Do not put switches in the neutral. It will work, but it defies the purpose. Thank you. You lot probably have seen that before, huh? It does happen, it's okay. I did that. So what is the resistance of a parallel circuit with the resistances of 2, 4, 6, and 10? Anybody want to volunteer and do this? Or should we? I'll do it. If I do it, are you gonna write it down, or I'm just doing it for nothing?
All right, let's do it.
Let's do it. I got it ready. More practice. So I finally learned the reason for this issue with the board.
Look at that.
Huh?
Look at that.
You know what is the issue?
The markers.
No. I thought it was the marker, but it's not the marker.
Upper air.
See, erases.
That's
Upper
the
air.
eraser.
Upper.
Because I had a eraser that you can peel. It's not the eraser.
Is it the board itself?
Huh? No.
Solution?
Solution that they clean the board with every day. It's soap based, so it's kind of oily. It does not strip all the oils out of it. I don't know what the guy is using over time. They cleaned a lot of grease. And so I contacted the manufacturer and they said like, you should use alcohol based cleaner. Otherwise it will do the same thing. So I was erasing here, it was okay. So Voila. This is what I do.
Technology.
This is what I do in my free time. Okay, so 4 resistances.
You discovered it. That's fine.
What did they say? 2 ohm, 4 ohm, 6 ohms, 10 ohms. Okay, so good? I'll start like I'm doing things in series. 2 plus 4 plus 6 plus 10. Flip. Divide. What's 1 over 6? 1, 3. No. Not with fractions.
0.16.
4.16. Add. Seven, 8, 9, 9, 6. That one is in front of me and don't forget this is the most important step. So people stop at it. It's a big mistake. Do the last thing, which is RT equal 1 over 1.01. .99. You can put 1 on. Check if the smaller the smallest one in the circuit. 4 resistances. Make sense? Okay. It's going to be the same. What is the total draw of a parallel circuit with an average reading of 2 amps, 7 amps, and 12 amps? Okay.
What, 23?
Yeah.
21 amps.
Yeah. You add them together, right? We said that you add up all the amperage together. What is the voltage of a series circuit with 4 voltage drop of 30? So each light bulb you drop 30.
120.
Yeah. You understand why? Because you're gonna keep dropping every time 30 volts. So you'll have, the drop is how much you took out. So when we did the light bulbs again, I like the light bulb example because you got to try it out. So first light bulb, second light bulb, 3 light bulbs. Boom, boom, boom. We go all the way here. So from here to here was 120. Second, if you drop 30, you're gonna get 90. From here to here, you're gonna get 60. And here, you'll get 30. And over here, 0. 0 volts. We'll keep dropping voltage as we go along.
If you had another light bulb, would it drop 5 times, or would the last light bulb not work?
It's not gonna work. You'll have continuity, but it's not going to work. It's gonna be completely like nothing happened. But it'll work just as a single wire.
There's
So,
no way of adding, more voltage past that point without bringing up,
no.
no way to do that
You can put a transformer.
in between, and that
Yeah, you could do that. Then we go into, there's so many ways to play with the circuit. That's what they do in electronics. You can stop the charge, you can delay it, you can put a timer, you can intensify it, you can go from AC to DC, and that's the whole beauty of electronics. And we do this for controls, actually, it's a good idea, because they do, timers are more, basically small capacitors, timers. Quartz are used to like also give you some kind of timing. I did tell about the quartz watch, right? Like how do we do time? That's in the other class, combustion control. But when you have early watches had springs, right? You have to wind them every day, and by the time the spring goes back and forth, that's 1 second or something. Or the pendulum watch, it's just like timing. Then they came up with quartz, which is a small stone, but it takes. It's a semiconductor, so you can run current through it, and the time between one end to another end of the quartz is 0.1 of a second. So as it goes back and forth 10 times, you can know that it's a second. That's how you make timers. So electronics go on with a lot of those timers and resistances. That's another class, we'll talk about it a lot later. Series, what is the resistance of a series circuit with the resistance of 4, 8, 12, and 22? What are you gonna do? Add them together. That's it. Okay. Let's see what else do we have. That's chapter 3. Chapter 4. Yeah, pretty close. We're good. Let's go on to our